Essentials of Inorganic Chemistry. I am your friend Dr. V.D. Bhatt, presently discussing a chapter, Safety and Hygiene in Chemical Industry. This is the fifth talk in the series and the fourth talk on the title, Safety Terminology in Material Safety Datasheet, that is MSDS. Friends, earlier we have seen that in the MSDS, one has to provide certain informations regarding the chemical that they are supplying. We have already discussed the informations on identity of the chemical, physical and chemical data of the chemical, fire and explosion hazard data, and today we are going to discuss the reactivity data of the chemical. So under this title, the first label is chemical stability. Now friends, stable compounds are the compounds that do not react easily. Chemical stability is the ability of a material to remain unchanged in the presence of heat, moisture or air. Whereas the unstable compounds, they easily decompose or polymerize or burn or sometimes explode under even normal environmental conditions. Let us see some specific chemicals. Carbon disulfide. This is a very popular industrial solvent, particularly used in rubbers. Now this carbon disulfide decomposes in light and it burns due to heat. It can catch a spark, it can catch a flame, or even a friction may result in the burning of carbon disulfide. Now when this carbon disulfide burns, it gives up fumes, and these fumes are toxic. You know, the formula of carbon disulfide is CS2 and the burning is in presence of oxygen. Therefore, upon burning, carbon disulfide will produce different oxides of sulfur. I have named them as SOX. It can be SO, SO2, SO3 and so on. So that was an example of carbon disulfide. Now, there is a compound named Caprolectum. This Caprolectum is very widely used in nylon manufacturing. It is an intermediate while preparing the nylon. So this Caprolectum, like carbon disulfide, it tends to liberate various oxides of nitrogen, that is NOx. Similarly, if you have compound trinitrotoluene, you know it is an explosive, abbreviated as TNT. This TNT, if it is stored, there is a chance that it will explode because of some shock or even by increase in temperature, that is heating, and thus some accident may occur. So the conditions that can disturb the stability of a compound should be known and should be provided in the material safety data sheet. So that was about the reactivity. Next we come to the incompatibility. Now you know, compatible materials are the materials that can stay together without any problem. So compatibility is the ability of two materials to exist in close and permanent contact for a long time. Liquids and solids are compatible if the solid is soluble in liquid. So, you know, water is compatible with alcohol because you know alcohol As such, alcohol and water both are liquid. We are now talking about liquids. So alcohol is soluble in water and therefore it is compatible. But when you take say petrol or diesel or kerosene, then they do not mix with each other. They are immiscible. So they are incompatible. Now incompatibility means disability or inability to coexist permanently. Therefore, incompatible materials should not be stored or kept together. For example, if you take toluene, then toluene reacts violently with some acids, plastic or rubber, and therefore these substances should be kept away from toluene. Now, incompatible materials, if you keep them together, then they can cause fire, explosion, release of toxic gases, violent reaction, polymerization, or at least destruction of the structure or function of the product. So, knowing the compatibility and incompatibility is very important for storage and handling of different materials. Now we come to the third level, reactivity. So reactivity, chemicals can react with each other to give product. A very simple example, hydrogen and oxygen can react to give water. So in this case we are showing two different chemicals, H2 and O2. Sometimes you will find that even a single chemical can react with air or water to give some product. So for example, phosphorus. Phosphorus in air will burn to give different oxides. P2O3, then you have phosphorus pentoxide, etc. In the same way, sulfur has tendency to burn to give sulfur dioxide. So these are different reactions. The first case was the reaction involving two different molecules, whereas in the later examples we saw that even a single molecule under the influence of air can produce products. So reactions can be exothermic or they can be endothermic. Reactions are called exothermic if they give out heat, and the reactions are called endothermic if they need heat to maintain them. If you need to keep on heating the reactants to keep on getting the product, then the reactions are endothermic. Whereas in case of exothermic reactions, initially if some heat is available, then the reaction will start and the heat will be released from the reaction, which will be used for the reaction of further molecules. So that was about exothermic and endothermic reactions. Now see, a reversible reaction. It is a reaction in which the product is unstable, and because of that it can go back to the reactant, that is the original substance. A reaction in which if the product is unstable and it again gets converted into reactant, then it is a reversible reaction. Now you have phosphorus, carbon disulfide, sodium metal, acids, etc. These are known for their reactivity in the environment. These informations are useful for storage, handling, and the purpose of process safety. Now let us come to the fourth and the last point in this, the hazardous reaction products. Now most of the times we know the chemical that we are handling, that is the reactant, but sometimes we are unaware about the properties of the products that are going to be formed upon the reactions. So hazardous reaction products, the products of the reactions, can sometimes have hazards, and it must be known before handling. So this must be known for the safety of process, workers and the environment. Here, products are more important than the reaction because of their hazardous nature. Example, chlorine reacts with alcohol and forms alkyl hypochlorite. This alkyl hypochlorite is explosive. So, in a reaction you may be knowing about the properties of chlorine, you know about the properties of alcohol, but if you don't know about the properties of alkyl hypochlorite, then there are chances of explosion. So therefore, the properties of the hazards of the reaction products must be known. Now, if toxic fumes are to be generated, then scrubbers are required. The scrubbers can absorb the fumes. Whereas if flammable vapors are generated, if vapors that can easily catch fire are generated, then you have to cover them with a blanket of inert gases, and earthing of the vessel is also necessary. Then if the reaction products are highly poisonous, that is maybe cyanides, if you are dealing with cyanides, then you cannot carry out the reactions in open system. You have to carry out the reactions in the closed system. So this was about the reactivity data of different chemicals. So with this, I end up the discussion on the material safety data sheet, the terminologies in the material safety data sheet. In the next lecture, I will be discussing about the different types of furnaces, their uses and the safety measures. Till then, thank you and goodbye.